right, we're going to do a quick review warm-up just to make sure you remember square roots. We're going to be working with the square root function today. So the square root of 36 is positive or negative 6, because positive 6 times positive 6 gives you 36, and negative 6 times negative 6 gives you 36. So 144 would be positive or negative 12. 400 would be positive or negative 20, and then there's this negative out front, so let's just go ahead and put the negative 20 because of the negative out front, even though it could make the negative 1 positive. So how about if we do this crazy thing, but really it's still positive or negative 20. And this is impossible. It's for right now. It's an imaginary number. And we're going to get to that in the near future. So the next chunk says to solve each inequality. To solve this one, we would subtract 5 from each side. So that would be x is greater than or equal to negative 5. I'm going to rewrite this in proper order. I like my x's on the left. So the Pac-Man is eating the 4x minus 8. We're going to keep it that way. We will add 8 first. And then divide by 4. Same thing here. If you get your x on the left and write the Pac-Man in the proper way, it's going to make it a lot easier to graph these two. So when you divide by 3, you get x is greater than or equal to 0. And then you would subtract 10. So we have negative 3x is greater than or equal to negative 10. And then when you divide or multiply an inequality by a negative, you have to flip that inequality. We did this earlier in the year and talked about how on a negative number line, everything's opposite. In positive world up here, 2's are smaller than 5's. But if you look at the negatives, 5's are smaller than 2's because negative 5 is less than negative 2. So since the opposite thing happens in the negative number line than the positive, we would need to flip that inequality. And then negative 10 over negative 3 is 3 1/3. So if you know that the square root of 49 is 7, then you know that this would have to be bigger. And if you know that the square root of 9 is 3, you would know that has to be bigger. All right. So a square root function is basically an equation that has a square root sign. So the first 3 all have a square root under the x, not just a square root sign. So these are not examples, and the square root of 3 times x is not a square root function because x is not under the square root. So next up, we're going to do a little story problem. Given the area of the square, determine its side length. So if we complete the table, if the area of a square is 0, the side length would be 0. A 2 by 2 gives 4. What times what gives 8? That would be the square root of 8 times the square root of 8. What times what gives 12? That would be the square root of 12 times the square root of 12. And if you want to put these decimals, since we're going to be graphing it in just a second, the square root of 8 is 2.828. And the square root of 12 is 3.464. The square root of 16 is 4. The square root of 20 is 4.472. The square root of 24 is 4.899. The square root of 28 is 5.291. The square root of 32 is 5.657. Square root of 36 is 6. And the square root of 40 is 6.324. So if we look at what a square root function would look like, and remember we're saying function because it's a one-to-one relationship. For every x, there's one y. So when we're talking about this as a function, we're not going to be looking at the negatives because let's graph this first, then I'll explain that more. Okay, so 0 gives 0. 4 gives 2. gives 2.828. 12 gives 3.464. 16 gives 4. 20 gives 4.47. 24 gives 4.89. 32 gives, 28 gives 5.2. 32 gives 5.6. 36 gives 6. And 40 gives 6.3. Now technically, the positive and the negative would work when you're taking the square root, but if you're talking about a story problem, it really doesn't make sense to have the negative side length. So we're going to go ahead and graph our square root function, which is kind of like a sideways parabola. If you thought about that all the negatives did exist, you do have this whole business down here, but that would make this not a function. So we're going to go with the domain of the story problem, and that is that only the positives are working. So now we have a function, 8 equals the square root of x, and this is the speed in feet per second of something falling after x feet. So we're going to find the speed of an object in free fall after it has fallen 4 feet. So we're going to plug 4 into x, and that's 2. And again, it wouldn't really make sense to use the negative 2 here because a negative speed doesn't make a lot of sense. So in most of these, we're just going to be using the positive. So we have 16. Feet per second. All right. We're going to look at the domain of each of these, which means we're going to have to know how to graph them. So, the square root of x would start at 0. And then if you think about 1, that'd give you 1. 2 is going to be that 1.414. 4 is a nice number, which is 2. But this square root function looks very similar to the one we just did. So the domain would be the solution set for x such that x is greater than or equal to 0. So negative 4 in for the x would give us negative 4 plus 4 under that square root, and then minus 3. So that would be 0 minus 3, which is negative 3. So we're going to be getting numbers in the y that work for everything negative 4 and greater. Negative 5 would make that square root a negative, and right now that is still an imaginary number that we don't know about yet, so we're not going to worry about that just yet. So if you put in negative 3, you would get a number. So negative 3 plus 4 is 1, and the square root of 1 minus 3 is negative 2. So this graph is going to start back here at negative 4, and it's going to be shifted down 3, and 0 would give us negative 3. 0 would give us 2 minus 3, which is negative 1. So it's going to swoop like that. So this domain is the solution set for x such that x is greater than or equal to 4 negative, because that's what will make this work right there. Okay, in the next one, what will make that work is what makes this thing, the first thing that makes it 0 is a positive 7. So anything less than a positive 7 is going to make the square root negative, which is an imaginary number, which we're not dealing with yet. So 1 plus 0 would be 1. And then you can plug in more numbers past 7, like 8. 8 minus 7 is 1, so 1 plus 1 is 2. But regardless, this one's going to start over here at 7. That's supposed to be be a graph. And again, it's going to be swooping like so. And the last one is a little weird because we need to figure out what makes this equal to 0. So when is 2x minus 5 equal to 0? This is very similar to what we just did factoring, where you would add the 5 and then divide by 2. So x is 2.5. So if we plug 2.5 in for x, 2 times 2.5 minus 5 is 0. So 2.5 would give us 0. And everything bigger than 2.5 will give us some sort of lovely number. So like if we plug 3 in, 2 times 3 is 6, 6 minus 5 is 1, the square root of 1 is 1. So everything above 2.5 will work. So if we look at that graph, 2.5 gives us 0, and then we've got that square root curve again. So let's talk about the shifting now with the graphs. I'm going to pull the graphing calculator up and see if we can look at 2 screens at once. Here we go. We'll try this. Okay, so the first equation, actually what if I go even, oh this will work, perfect, is under y equals the square root of x plus 4. So let's go ahead and just look at the square root of x first. Here's my graph. Alright, so it starts at 0, and then these are the data points that we've plotted already. So we're going to go back here, and we're going to see how the square root of x plus 4 on the outside changes this. So the square root of x, and then I need to get that square root off, because that's very different than this, which we're going to do next. So that shifts it up 4. See how it's gone up 4? So let's go ahead and write up 4. Okay. Now let's go back here. And let's do this next one as x plus 4. So the square root of the whole thing, x plus 4. And that shifts it left 4. Very similar to what the quadratic equations did. Because negative 4 is what makes this 0, and it needs to be 0 or more to be able to take the square root and get a number that will work. Okay, so then this x minus 3, if we go back here, I'm just going to change my 3 down here to a minus. And since this shifted it up 4, what do you think this is going to do? I would guess it would shift it down 3. And there you go, down 3. So let's go ahead and write that. And then the next one with an x minus 3 inside. Since x plus 4 shifts it left 4, x minus 3 is probably going to shift it right 3. And there it is, right 3. Alright, so now let's do this 5x. So what do you think is going to happen if we do 5 times the square root of x? So 5 times, oops, I'm doing the wrong one, square root of 5x, square root of the whole thing. So that appears to make it steeper. How do you think the 5 out front, what do you think that's going to do? the 5's out front, 5 times the square root of x wow, that makes it quite a bit steeper because you're multiplying the square root of x answer times 5. So this is where it becomes 5 times steeper. Okay, let's continue on this group 4. We'll come back to this group 3 in just a second. So let's go ahead and look at 0.5 times the square root of x. And while we're at it, we can put in the negative 5 times the square root of x also. So we've got our positive 5 times the square root of x, our negative 5, which flips it on the x-axis and makes it go down. And then, so this is going down. And then the 0.5 is this little itty bitty one that cut it in half. So it's half as steep. Okay, hopefully you can read that. All right, so in group 4, the number on the outside makes it steeper if it's bigger than 0, bigger than 1, less steep if it's less than 1 yet positive, and if it's negative, it's going to flip it on the opposite side. So what's happening with this? Let's put this group 3 in. So we've got 5. I'm just going to clear this whole thing. Square root of 5x. And then we've got square root of 0.5x. And then we've got square root, and this is a negative under the square root. Negative 5x. Okay, so we've got our 5x, which is a bit steeper. We've got our 0.5x, which is a bit steeper. And then we've got our negative 5x, which means that's only going to work for the negative numbers. You see how that negative 5x went this way? Because the negative numbers make that positive. So this is a flip over the y-axis. Where this is an x-axis symmetry. And then how can we explain what those two do? So this is just a slight increase. And this is a little less steep. Wow. It's kind of hard to write with the mouse here. All right, so hopefully these translations are making sense, and have a good night.